Hey guys, today is lesson 5.3, models for subtraction. Our learning targets specifically are to use using subtraction to compare different things and then calculate change and or leftover amounts. And the second part is to use the algebraic definition of subtraction to rewrite it as addition. Essentially from here on out, all of our subtraction will be changed over to addition. Taking a look here, we're going to dive right in without a warm-up. We're going to talk about the add-up prop. This is technically called the algebraic definition of subtraction. This is how we're going to change any subtraction problem into an addition problem. This is what we will do for the rest of the year, so familiarize yourself with it. A minus b is really the same as a plus negative b. What happens is that the minus b tells us that the b is actually the opposite of whatever it is supposed to be. So the subtraction, instead of being a subtraction, is an addition, with that subtraction applying to the next number, adding an opposite or a negative. A couple of examples of this would be if we're dealing with 3 minus 5, the subtraction becomes an addition, and then the minus applies to the next number as an opposite or a negative. So this is really 3 plus negative 5, which we all know is negative 2. Number 2 here, our addition is going to reapply itself as a subtraction, or excuse me, our subtraction is going to reapply itself as an addition, and then the subtraction will apply to the next number as a negative. So this 9 minus 9 became a negative 9, which we all know to be negative 13. In the third one here, we have negative 7 minus negative 10. This is where things get really tricky, and this property comes in very handy. The subtraction becomes an addition, and the subtraction itself is applied to the next number as a negative. So what was once a negative 10 is now a opposite of negative 10, or a positive 10. So this is negative 7 plus a positive 10, which we all know to be 3. We're going to see that again a little bit later in a few examples that you'll try on your own. But first we're going to talk about the takeaway model. We want to make sure that this is applied to quantities that have the same unit, where the leftover amount is equal to the original amount minus whatever is taken away. For example, if Ernie had M cookies and Cookie Monster ate 5 of them, how many cookies does Ernie have left? Well, in this, our original amount is M cookies, the amount that Ernie had. The takeaway is the 5 cookies that Cookie Monster ate. So there are M minus 5 cookies left. The comparison model tells us x minus y will tell us how much more x is than y. So it always tells us how much more the first one is. This would come out to be a negative value if x is actually less. If I want to know how much more x is, and it's really smaller than y, I'll end up with a negative amount. For example, if Jack Spratt weighs 90 pounds, his wife weighs 150 pounds, how much more does Jack weigh than his wife? Well, we know technically he doesn't weigh more, but following the model, we'd do 90 pounds minus 150 pounds, which is negative 60 pounds. Jack weighs negative 60 pounds more than his wife. Change is calculated by taking a newer value minus an older value. For example, if I had $27 last week and now I have $15, what is the change in my amount of money? The new minus the old, the new amount is the $15, the most current amount, minus the 27 or plus negative 27, giving me a negative $12. Finally, we're going to talk about a couple of examples. You should try each of these before revealing the answer. So the first step would be to rewrite each of the following as an addition, where we're actually going to change everything over to subtraction, or change over all of the subtraction to addition, and then we're going to evaluate. And I'm going to go ahead and let you know that x in this case is equal to 5 and y is equal to negative 2. So take a moment, press pause, try these on your own, and then reveal the answers. Number 1, the one subtraction that we see here, the minus 5, would be changed over to an addition, which would then make it a negative 5. Substituting here, x is 5 from the directions. X is a 5. So we substitute. Generally, we substitute using parentheses to ensure that we have substituted the correct value. Following through here, since addition is commutative, I can choose to do these two first, which I did, negative 5 plus 5. These is opposites, giving me a 0. So we have a value of 3. In number 2, part A, changing over to subtraction to addition, instead of minus y, we can turn that into an addition, with an opposite of y. Before we can do part B to evaluate, we do have to substitute in x is a 5, y is a negative 2. You'll notice that the opposite that was already a part of the expression is not the same as the opposite that is on the negative 2. So with the opposite outside of the y, we really end up with 2. Y is negative 2. This is the opposite of y, so we have the opposite of negative 2. Upon evaluating here, I will notice that the negative 2, the opposite of the negative 2 is 2, so we come out with a value of 9. And finally, in number 3, we do have 2 subtractions to change over. Instead of a minus x, we have plus the opposite of x, so we applied an opposite on the x following the subtraction. Instead of minus 4, we have plus the opposite of 4. In order to follow through on part B evaluating, we do need to substitute. X is a 5 and y is a negative 2. So again, you'll notice this is the opposite of x, so it is the opposite of 5. Upon evaluating here, addition is commutative, so I'm going to add the first 2 add-ins, the first 2 terms, and then I will add the second 2 terms as well. Since it's all addition, I can add the first 2 terms together and add the second 2 terms as well, coming out with a value of negative 21. We'll run through a few more examples in class. We'll see you then.